So guys, we had discussed the basic part, that is units and the physical quantity, and now the most important part of this chapter is dimensional formula, the second part, which is the important part because the first part was basically a easy one or basic one, dimensional formula. So this is something different you hadn't heard as of now. So dimensional formula, so what does it represent? Is actually dimensional formula is like is a formula used to represent a physical quantity. And how? By raising the powers to the basic physical quantity, basic physical quantities. So I'll give you an example. Basic physical quantity like mass, length, time, electric current, temperature. So we represent any xyz physical quantity in terms of these basic physical quantity, m, l, t, or temperature, or so abc. I give the exponents this name. Okay, current with represented with capital A. So thereby, if so, this is the way of representing physical quantity dimensionally. Okay, and dimensional formula of every physical quantity is different, that is of different physical quantity is different. So for example, let's work over some physical quantity like acceleration. So acceleration is, what is acceleration? Is rate of change of speed with time or velocity with time. So acceleration unit of acceleration is meter per second square. So if I need to represent this in terms of the dimensional formula, so meter is the unit of length, time is the unit of second is the unit of time. Okay, and if I say mass, so can you see any mass unit here, kg or something like that? No. So the power of mass would be 0, and the power of length L would be the power of m. What is the power of m? Is 1. Power of second is square, but it is like upon, it is not actually square. I can represent this meter second ka power minus half, meter to the power of second is minus 2. So the power of t I would represent minus 2, not 2. So this is the dimensional formula, or precisely it would be lt minus 2. Okay, so this is the dimensional formula for acceleration. Very simple, not a big thing. Okay, we'll discuss it more with the others physical quantities. And the famous physical quantity, force. Let's do it with the force. What is the dimensional formula of force? So what is the unit of force? Newton, or I can say that kg meter per second square. Okay, so let's do dimensional formula of force. Okay, let's try to represent this in what would be the dimensional formula of this. So here I have unit of mass as well, length as well, and time as well. So mass, length, and time. Now see what would be the power of mass here. What is the power of kg? 1. So mass is 1. What is the power of meter? 1. So length power would exponent would be 1. What is the power of second? It is square, but it is under, upon. So it's like more like minus 2. So what is the power of t I keep here? Minus 2. So this would be the dimensional formula, and majorly it is being represented by these brackets, these close brackets. Okay, so thereby you can practice the dimensional formula of any physical quantities. There are n numbers of physical quantities out there, so and dimensional formula for each of them is present. Okay, I can give you dimensional formula of many physical quantities, But the problem right now is you're not aware of so many physical quantities. Okay, you are going to encounter those in the upcoming chapters. So I'm not going to bombard or um, bombard you with those physical quantities or with those jargons right now. So let's practice over the simple physical quantity. One or something is like that. Pressure is one other physical quantity, an easy one. We all know the formula as well, force by area. So if I ask of the unit for pressure is Pascal, and precisely it is force kg meter per second square divided by meter square. So can I write it like kg meter per second square? Am I right? Or precisely kg meter power is -1, second power is -2. So this is the unit of pressure. So if I talk of the dimensional formula for pressure, so I need to represent it with mlt. In terms of mlt, what would be the power of m over here? What is the power of kg? Actually m represent mass, so just go with the unit of mass, go with the unit of length, go with the unit of time. Okay, so what is the power of kg is 1, so power of mass would be m would be 1, and of that m, that's why length meter -1, and second that would be of time is -2. So this is the dimensional formula for pressure. Okay, so I can play with n numbers of physical quantity over there, but there is no use of that. Now let's jump into one other important subtopic, which is the significance of dimensional formula. So you must be wondering, what is the significance of these dimensional formula? Why do we need them in the first place? So there are some good points about the dimensional formula. I would give you the pros of dimensional formula analysis. First one is it helps to check the validity of a equation, validity of an equation or formula, equation or formula, and it is useful in some of the exams as well, MCQs exams as well. You can use them, this property of dimensional formula, if you are smart enough or aware enough. Say for example, I know the dimensional formula of force, okay, which is m l t minus 2. Okay, now I know the formula. Somebody told me the formula for force is this. Okay, mass into acceleration. So I know the dimension formula of force. If the dimension formula of the left hand side is equivalent to right hand side, then this formula is right. So let's check the dimensional formula for the right hand side. So let's check the dimensional formula of the right hand side. Okay, I'm writing for the right hand side. First one is of mass into acceleration. So I just segregate them. For mass it is m to the power 1. For acceleration, if I talk, so acceleration in meter per second square, unit is meter per second square. So meter is for length per second square, that means second to the power -2. So if I combine them, so it is coming like this, which is obviously equal to the left hand side. So the thing is, formula is correct. Okay, so I give you one other one for the practice. Say for example, there is a formula like P times equal to m time equivalent to m times v velocity, that is the momentum. So this is a formula for momentum. We need to check whether it's right or wrong. So somebody gave us the dimension formula of momentum, which is m1 l1 t to the power minus 1. Now what I need to check the right hand side, only right hand side. Right hand side is mass times velocity. So what is the dimension formula of mass? Is m to the power 1. What is the dimension formula for velocity? L t minus 1. For the velocity is meter per second. So meter per second. So for meter is length, per second is time. So this is the dimension formula for velocity. So if I combine it again come m1 l1 t to the power minus 1, and that which is equivalent to left hand side, which is thus proves the formula is correct. So you can now feel that the advantage or the importance of dimensional formula. I give you another importance. This is regarding the formula. Then we can talk for the same with equation as well. So when I talk of equation, theorem comes like it's in the books, so it's nothing so complex something. Principle or theorem, principle of homogeneity, which is nothing but a simple thing that you can only add or subtract physical quantities having same dimensional formula. So what I said, you can only add or subtract things, physical quantities having same dimensional formula. Okay, so what does that mean, add or subtract? That means like you can only add 5 kg and 7 kg. You cannot add 5 kg plus 7 second. This doesn't make any sense. Okay, I'm not talking about dividing or multiplication. I'm not talking about division or multiplication. Is here the operation we are concerned is addition or subtraction. So the thing is, we can only add or subtract among the same physical quantities, na? So that's the same thing. Okay, you cannot add like 7 Newton force plus 8 kg, 8 meter plus 2 second. These are invalid, these are invalid operations, or it doesn't signify anything. So that's the principle of homogeneity. That's the dimension of such variables should be same. Say for example, and so in equation, how does we use it? Okay, I'll give you this example. Say I say v minus a t plus b equivalent to 0. So this is an equation, the whole term is an equation. Now I know one thing, the dimension of v is the velocity over here. I give you v is velocity. T stands for time, seconds. Okay, everything is in SI unit, standard unit. Every variable, every physical quantity is in standard units. Okay, so if I ask you what is the units, what are the dimension of a, variable a and b, the dimensions of variable a and variable b. So this is the question, think over it.